You've probably seen these sort of battery checkers that we use for receiver batteries on model aeroplanes. Here's a fairly flat battery. If I plug this one in, you can see we just got one red LED, and then this battery here is reasonably healthy. It's not completely fresh off charge, but it's pretty good. If I plug this one in, we're on the top but one LED, which is green. And now I've hooked it up to a power supply and a voltmeter, and you can see if I wind the voltage up and down, we've got red LED at the bottom, and then we've got a few amber LEDs, 3 amber LEDs or yellow, and then 4 green LEDs. And I've set it so that at the you need about 5.36 volts for full, and then it comes down. Each LED represents 80 millivolts, so by the time you get down to 4.8 volts it's showing empty red, and you'll notice it carries on working the device down to let's see, down to 3.5 volts or less, by which time of course the battery's totally flat. And those are about the right voltages for NiCads or nickel metal hydride. It won't hurt the gadget if we go up to 7 volts or more, to about 12 volts it'd be okay, because it's going through the regulator. Incidentally, for this sort of calibration work, I made this device using a cut-off lead from a Y lead. That's what that plug is. It's cut off from a Y lead, and the original part of the Y lead is the best way to calibrate it, because you can hook your voltmeter up to one of the wires coming out of there, and then you're measuring the voltage actually at the plug, because there's hardly any volt drop. Obviously down the wires to the voltmeter it's only taking microamps, and you're supplying the applied voltage along the other lead, and any volt drop down that lead doesn't matter, because you know you're measuring and calibrating it with whatever voltage is at the socket, which is the way you want to do it. Now this little I'll switch the meter off. This little gadget is based on an Arduino clone, and I'll now, it's got a 3D printed case, as you can see. It says 4 cell on the one side and nickel on the other, and to calibrate it you need to apply those 2 chosen voltages. As I say, I used 5.36 and 4.8, and link a little, apply a little link wire to the board, and then it samples that voltage, stores it in its EEPROM memory, and then it's calibrated, and you can close the case up and you should never need to open it again. I'll show that in the next clip. Okay, so this is how we calibrate the low voltage. You set the supply as near to 4.8 volts as you can get, a couple of millivolts over there, and then you short pin 7 to ground. So on here it's the 3rd pin along to the 7th one. You see, when you do that you get this little stepping pattern. I'll just do it again so you can see it. And it's stored that value now as the low calibration. High calibration is exactly the same. Set the appropriate voltage, and in this case you short pin 13 to ground, and again you get the stepping pattern.